So we were discussing the problem construction of DFA for regular expression, this one, and we have drawn as well the NFA with epsilon move for this expression, which is like this. Okay, now since they have asked us to draw the DFA, we need to convert this NFA with epsilon move to a equivalent DFA using direct method. So actually I have recorded throughout the process of drawing this, but due to some technical issues that video could not be saved. So I am repeating once again with this discussion, but only thing is here everything is ready, I have to just explain it. So here how I will express. So this is my NFA with epsilon move, which is having total 28 states, 0 to 27, that is total 28 states, and now we are interested in drawing DFA, corresponding DFA for it. So we will start from 0 state. With 0 state we can see that how many states, this is the first state, so in the capsule there will be only one state named as 0. Now in the another part of this capsule we have to write the NFA epsilon closure for this 0, and that is all the reachable states from this 0 state. Okay, so which are those states? Those states are 0. With epsilon move it can move to 1, it can move to 2, it can move to 6. Then with this path, this particular path, it can also move to 11, that's why 11. It is also moving through 11 to 12 with epsilon move. So this will be the epsilon closure for the state 0. Then we are moving to the state identification with the input symbol A and B. So we will check for each state here what will happen or where it is going with the input A. So 0 on A moves nowhere, then 1 on A nowhere, then 2 on A, yes, it is moving to 3 states, so we have written this particular 3 here. We have not checked all the states, that's why I have not completed this particular capsule part. So next is again we have to check it for 11. So 11 state with A moves nowhere, but this 12 state with A moves to 13. So now in the first part you will be having 2 states, A 3 and 13, which is actually the combination like this in a square bracket. So 3, 13 will be in the first part. What will be then the next part? All the reachable state with these through states with the epsilon move. So 3 on epsilon moves to 4 state, that's why 4. Any more states? No other path is available from 3 with epsilon move other than this, so only 4 is included. Now there is a turn of 13 state. So 13 state with epsilon move moves to 14. Again there is no other path from 13 with epsilon move. That's why here in the second part it will be 14. Similarly from this state, 0 state with B, we have to check. So 0 with B nowhere, 1 with B nowhere, then 2 with B nowhere, then 6 with B is moving to 7. That's why the state is 7. Then 11 with B nowhere, 12 with B nowhere. That's why only 7 will be in the first part of a capsule. Now we have to find out the epsilon closure of 7. So this is our 7 state. Its epsilon closure is this 8. Any more states which are reachable from 7 with epsilon move? No other states. That's why there is only 8. So we have considered these 2 states. Okay, these are the 2 new generated states. Now we have to take one by one all the states and find out the next state for these states with the A and B input symbol. So now here as you can see with this state 3 and 13 on A. So 3 on A moves nowhere, then 13 on A moves nowhere. Then there is a turn of 4. So 4 on A moves nowhere, then 14 on A moves to, so 14 on A moves to 15. So there will be a state 15 generated which is with the input symbol A. Now we have to find out the epsilon closure for 15. So this is my 15 state. Now you can see, now we are moving to next parts from here. With epsilon move, I am moving to this state 16. So very first state which is reachable with epsilon move is this 16, then 17, then 18, then 22. 17, 18, 22, and with this particular move it is moving to 27. So this will be the 15th state. Now since 27 is involved, we have to make this state as a final state. Next, with B, I am moving to which state from this state? So now where is my 3? This is my 3. So 3 on B moves nowhere. Then 13. This is my 30. 13 on B moves nowhere. Then 4. 4 on B moves to 5. Yes. So we have to consider. And then 14. So 14 on B moves nowhere. Okay. So only which state? The 5 state is reachable with B from 4 state. That's why the B with B it is moving to 5 state. So again we have to find out the epsilon closure for this 5. So 5 with epsilon closure moves to, that is 5 with epsilon moves to 10, then 11, then 12, is it? See here, 10, see 11, 12 as well. With this back movement with this blue color, you can see with this 10 it is also moving to 1, through this 1 it is moving to 2, and through this one it is also moving to 6. So all this state 10, then 1, then 2, then 6, then 11 and 12. All this will be the part of the epsilon closure of 5. So the turn of this state is over. Next is the turn of this state. So here we can see, so 7 on A moves nowhere, then 8 on A moves to, yes, it is moving to state 9. Okay, so this 9th state is generated. Again we have to find out the epsilon closure for this. So epsilon closure for this 9 is 10, then with from this 10 it is also moving to 1. Okay, so 10, then 1, then 2, then 6, as well the 11 and the 12. All these states will be just like we had in this state. We had all the states in this state which is named as 9. Okay, so after this again we have got this state and this states. Okay, so again we have to find out what will be the transitions for this state. So if we consider 5 state, this is 5 state. So this 5 with A moves to anywhere, no. Then 10 on A moves nowhere, 1 on A moves nowhere, 6 on A moves nowhere, 11 on A moves nowhere, but 12, this 12. So this 12 on A moves to 13. So we had already the state, see here once again. So 10 on A moves nowhere, then 1 on A moves nowhere, then 2 on A moves to 3. As well the 6 on A moves nowhere, 11 on A moves nowhere, and 12 on A moves to 13. Okay, so we are reaching to the same state 3 and 13 which is already available with A. Similarly with B from 5. So with 5, so with B nowhere, then which is the state? 10. 10 with B nowhere, 11 with B nowhere, 12 with B nowhere. Then which are the remaining state? 1 with B nowhere, 6 with B moving to 7. So we need to have this particular transition. Similarly, so this part is over. Now the state 15 is remaining. So 15 on A This is my 15 state, which is only moving with the epsilon. So nowhere we can represent. Now 16 on A also don't move anywhere. Then 17 on A moves nowhere. Then 22 also moves nowhere. Then 27 also moves nowhere. Okay. So this state on, is it moving anywhere? Once again will, yes, 18 on A. 18 on A moves to 19. So this 19 state will be there. Okay. Then again this state with B moves to. So 15 nowhere, 16 nowhere, 17 nowhere, 18 nowhere, 22 it is moving to 23. So it is moving to 23, this one state. So 23, and then we have to find out the epsilon closure. For 19 it is only 20, so 20 is written. For 23 the epsilon closure is 24. So we have got these two new states now. So we have to consider again transitions for these two states, right? So now here 19 on A moves nowhere, 20 on A moves nowhere. So there is no transition for this state with A. Next 19 on B moves nowhere, but 20 on B moves to 21. So there will be a transition to a new state, which is 21. Okay. Then 23 state. So 23 on A moves nowhere. Then 24 on A moves to 25. So again we got new state 25. Now we will find out epsilon closure for these two states. So 21 epsilon closure will have 26, 27, again with this path to 17, then 18 and 22. Just see here, 26, then 17, 18, 22 and this 27. Since 27 is involved, we have to make this as a final state. Next, this state 25 on epsilon closure, again it is moving to 26, so it will be same, 17, 18, 22 and 27. Okay, so this will also be a final state. So these two states are generated. We have checked for this, we have checked for this. Now we have to check it for this. So this state on A moves where? So 21 on A moves nowhere, right? 26 on A moves nowhere, 17 on A moves nowhere, then 18 on A moves to 19. So it is moving back to this particular state. Okay. Now what about B? So again with B it will be just like we had the case. Just see once again. So 21 on B moves nowhere, 26 on B moves nowhere, then 17 on B moves nowhere, 18 on B moves nowhere, 22 on B moves to 23. So it is moving to 23 state. So this state is also considered. So now finally is the turn of this state. So with this no new states are generated with A or B. Now there is a turn of this 25. So 25 with epsilon move. This epsilon closure is already written here. Now we have to check it for with A where it will move. So 25 with A moves nowhere, 26 with A moves nowhere, 17 with A moves nowhere, 18 with A. Yes, it is moving to 18 with A moves to 19. So this path is drawn here. Then 22 moves nowhere and 27 as well nowhere. Similarly B, with B it will be moving, see, with 25, 26, 17, 18 nowhere, but with 22 it is moving to 23. So 23 state is there. So the path is written like this. So when we have drawn all these states, now we have come to a point that no new states are generated for this particular given NFA with epsilon move. Now whether it is a final DFA, so you already aware that whenever we are drawing the DFA, it should be checked for minimization. So very first what we have done, we have drawn the table by nominating each state. So A, B, C, D, E, F, G, H, I and J. So these many states we have got with the direct method, and we have drawn a state transition table for this. So I have written here A, B, C, D, E, F, G, H, I, J. Now what are the observations? Observations are that equivalence is existing here. Okay, so in this what you can see here, C state is equivalent to C. DG is a final state. C is a final state as well. Our H state is final state and J states are final states. So C state, H state and J state are final state. Again, if you will observe their transitions, DG, for this also it is DG and for this also it is DG. So all these three states are equivalent. So what we will do, we will keep C and we will discard this H and J states. Okay, similarly we have identified the state BE. Okay, with A we are moving to BE. Same combination is available for F state as well as I, and all three are non-final states. These all are final state. These are all non-final. So we can set the equivalence. So again, wherever we are finding the F and I will be replaced by A. So see here it was F, so it will be replaced by A. Again it was I, so it will be replaced by A. Okay. Any more places? No. Similarly, wherever we will find H or J, we will be replacing it by C. So here it is H, so it will be replaced by C. Again, at this place there is a J, so it will be replaced by C. And we will be discarding again which states? F and I states will be discarded. So from this, after discarding 1, 2, 3, 4 state, we have remained with how many states? 1, 2, 3, 4, 5, 6. Okay. So considering this all states, we will be drawing the final DFA, which will look like this. I have just copied A on A moves to B, A on B moves to E. Similarly, B on A moves to C, B on B moves to A. Then C on A moves to D, C on B moves to G, this G. Then there is a turn of D, D on A moves nowhere, D on B moves to H, D on B moves to C, H is not there, it is replaced by C. Next is E on A moves to A and on B moves nowhere, only G is remaining. So G on A moves to C and G on B moves nowhere. So this will be your final DFA for the given regular expression, this one. So I hope you have understood the application of all the earlier discussion, that is NFA with epsilon move to DFA conversion and the usage of DFA minimization. Okay.